In the previous video, we looked at an overview of how to use the Automation Director REST API. In this video, we will start with a reminder of the required process and then take a look at each step in turn, using pseudocode examples where appropriate. As we saw last time, there are a number of steps to follow when using the Automation Director REST API. So let's start with a brief recap. First, we obtain an authentication token from the IMS server. Next, we ask the Automation Director server for the service ID of the service we wish to invoke. We then ask the Automation Director server for the properties of that service. We modify the properties, setting the parameters as needed, and we submit our request to invoke the service and include the service properties we have just updated. In response, the Automation Director server returns the task ID. We then monitor the task to completion, whilst making sure the authentication token has not expired. When the task enters a state of either completed or failed, we move to the last step. Finally, we obtain the task completion status. As you can see, during the process we need to communicate with both the IMS server and the Automation Director server multiple times. Now let's take a closer look at each of the steps. But before we do that, just a couple of points to mention. It is intended that the information provided here will be sufficient for you to invoke an Automation Director service using whichever programming language you prefer. The Automation Director REST API that we will be calling provides responses in JSON format. If you are unfamiliar with using JSON format strings, there are plenty of examples on the internet, and I've included an example here. Details of all services supplied with Automation Director and the parameters they require are contained in the HPE Automation Director REST API User and Reference Guide. This document is available at the link shown or by searching for the title of the document. The next video will provide some real-world code examples for each step of the service invocation process. Getting back to the process, on the left of the screen you can see each step in the process required to invoke an Automation Director service using REST API. We first make a POST request to the IMS server to obtain a new authentication token. In the body of this request, in JSON format, we provide the credentials for an account known to the IMS server. Assuming that our credentials are verified, the authentication token will be returned to us in the response. As we will see in the next step, the authentication token will need to be provided as a bearer token on all subsequent API calls to the Automation Director server. Now we need to obtain the unique instance ID of the service we wish to invoke. To do this, we make a GET request to the Automation Director server. The service name that we search for must be encoded as it is included as a parameter within the URL. That is why in this example, the space character in the service name has been replaced with plus symbols. We need the instance ID from the returned service details, this being the unique reference number for the service we wish to invoke. And to be sure we have the correct instance ID, we can check that the name of the service returned matches the name of the service we searched for. Using the instance ID, we can now make a GET request to the Automation Director server to obtain the properties for the service. The service properties is an array containing all the possible parameters defined for the service. Whilst not every parameter needs to be updated, those parameters pertinent to the request we wish to make do need to be modified. The easiest way to identify which parameters need to be modified is to manually submit the service using the Automation Director web interface. This will allow you to see any defaults the service assumes as well as the user inputs required by that service. At a minimum, you will need to ensure these values are correct in the service properties object before making the call to invoke the service. Here we see a section of the returned service properties object after it has been converted from a JSON string to an array. As you can see, the array of parameters that we get back from this request is numerically indexed, rather than indexed by the parameter name. To simplify access to these parameters, we can re-index this array by the parameter name which is provided in the key name field. Now it is possible to quickly refer to any given parameter value by referencing its name. Having finished making the required parameter changes, don't forget to revert the array back to its original numerically indexed form, otherwise it will be rejected by the Automation Director server. Having prepared the service properties, we now need to invoke the service. The full URL we need for this REST API call is already provided in the href parameter of the service properties, so we can just extract that value to make our next REST API call. To invoke the service, we make a POST request to the Automation Director server, providing the updated service properties object in the body in JSON format. In return, we are provided an invocation response, which contains a unique task ID. We need this to monitor the ongoing progress of our running service. The invocation response also contains the URL we need to call in order to monitor the task progress. However, because we will also need the task ID in a later step, it makes sense to extract it from the invocation response rather than just using the provided URL. Contained within the invocation array is an element called affected resource, this itself being another array. As we saw previously with the service properties, the invocation response array is also indexed numerically. Therefore, we need to locate the required element based on one of the values. This time, a simple loop through the affected resource array looking for the specified element value is sufficient. We retrieve the value of the task ID from the last part of the URL string that we find. While the service is running, we need to check its status until it has finished. We therefore enter a loop and periodically make a GET request to the Automation Director server to obtain the task status. As part of this loop, we also need to make sure that the authentication token has not expired. If it has, we simply request a new one from the IMS server. A task status of either completed or failed indicates that the task has finished. At this point, we can exit our loop and proceed to the next step. Our last API request is a GET to the Automation Director server, this time to retrieve the final status of the completed task. Amongst other information, this response will include the result and any output from the service we invoked. We can then extract from the response any information we require or perform any other checks and verifications needed. And finally, if we launch the Automation Director web interface, we can view details of the request, the data submitted and the results, as well as things like logs and a visual representation of every step executed for the task we created. The next video will provide some real-world code examples for each step of the service invocation process using REST API.